Everybody, Colin here again. Great to be here for the final session. It sounds like it's going to be a great morning for some science, and clearly we're going to be covering some aspects of robotics. So really looking forward to that.
Terrific, Colin. Thank you very much. And so yeah, let's have a look at what we're going to be looking at today. As Colin mentioned, our major focus today is going to be looking at the robotics aspects. You know, the thing is that quite often we learn a lot about science, we learn a lot about math, we learn a lot about technology and engineering. The thing is that it's actually, it all comes to the fore when we implement. You know, the thing is that knowledge is a platform for action. So the thing is that what we need to do is we always need to ask those questions. Well, so what, and what am I going to do with this? So what I'd like to do is I'd like to start off with a little bit of just a recap, and maybe actually just to set some context for our session today. Everything that we've been doing with the United Nations Development Program has been around the Sustainable Development Goals. So what we've been doing is we've been touching on number 7, which is affordable and clean energy. We've also touched upon 13, climate action, as well as 15, life on land. So yeah, what did we learn about? We learned a lot about light. To start off, we learned a lot about light. Our sun is absolutely crucial to everything, all life on Earth. What happens is that we orbit our sun, and we get all of our energy from the sun, whether it is directly in the form of light, or otherwise maybe it's heat, because our atmospheres absorb the heat from the sun's rays. And to a large extent, for the last few hundred years, we've been digging up all of those hydrocarbons, which originally were actually plants that got covered up, got buried, and converted to coal or crude oil, whatever it may be. So the thing is, we learned a lot about light. We learned about light intensity, which we refer to as lux. We also had a look at the energy that is in that sunlight that we receive, all the way from infrared through to the ultraviolet range. And here we have a very nice graphic that matches that in terms of number of photons that we receive, but also the energy profile of light that we receive, and then the impact that it has, how light and energy and heat get absorbed by our atmosphere, how we are protected by our atmosphere, by our ozone layer. And we also learned quite a lot about how we're protected by our magnetic field. But primarily, what we were looking at is we were looking at solar energy. And a number of you who actually went through the assignments, there were some really nice videos connecting how do we understand generation of solar energy. And also a number of you have come through with projects related to solar energy generation. Then what we did as well is we learned about, in a way, climate action, because a lot of what we need to do is in terms of climate action, and how we can stop or even possibly ever reverse climate change. It's a lot of it's around greenhouse gases. And what we did is we had a good look at what is the impact of those greenhouse gases in terms of creating this heating and this overheating that we have of our atmosphere. And we translated that into our comfort levels. What we've seen over the last few years is we've seen extreme fires, both in California, in Cape Town, in the Western Cape, we've had terrible fires, and also in Australia, they've had really devastating fires. Earlier this year, We saw Canada was burning for the first time. Canada was experiencing temperatures of over 40 degrees centigrade, unheard of. And everything was just drying out, and it was just one big tinderbox. So we are starting to really, really see the impact of that. 2 years ago with heat waves across the UK and across Europe, people were actually, they were people who had air conditioners in their houses were using those air conditioners because they needed to stay in this comfort zone that we have represented by this green rhombus over here. So you know, the thing is that the people who couldn't cool down, it actually resulted in a number of deaths because of the heat and the dryness. So that's where, so what we did is we related that in terms of our climate action, and we had a look at what is it like for the team living on Antarctica. They're doing a lot of research there, but it's really not very comfortable for them there. And then what we did as well is we had a look at life on land. Everybody received a soil moisture sensor. We've got great weather sensors and light sensors. And what we did is we learned also about Internet of Things, and how do we actually collect data and turn that into a platform for decision making for our robotics projects. So here I've taken a screenshot of my dashboard that I'm running for one of my chili plants, for the paprika chili plant. And so what we can see here is we can see these dramatic changes in light intensity. Here we can see the changes in the soil moisture levels, atmospheric pressure, temperature, I mean, UV. And what I have is I have connected a particle matter sensor. What it is that we're going into a period where we get a lot of veld fires and bushfires in Cape Town. And so what I've done is I've connected a particle matter sensor. This is actually a very new sensor to the X-in-a-Box ecosystem. So it's really still, we're still doing quite a lot of testing there. And so we thought, how do we actually have this apply? And so over here on the right-hand side, we can see this is our dew point and our frost point. And how does this relate on a curve in terms of vapor pressure, temperature, etc. And there is a calculator that we can use. There are plenty of calculators actually available online, where we take our temperature, and we also take our atmospheric pressure, which we have over atmospheric relative humidity, I mean, and we can actually then start predicting, are we going to have dew overnight? Are we actually going to have frost overnight? Which creates, once again, a platform for decision making for those who are growing our food so that we can survive. So what I'd really like to cover today is I'd like us to really go in depth in terms of our robotics projects and our robotics ideas. So with your kits, you also, you received a number of different outputs. You received the OC01, which is an output which you can use as a switch. And then also you have that really great servo controller, which can control up to 8 servos, so that what you can do is you can start moving robotic arms, etc. We have a deadline for the 30th of September for your robotics ideas. And from there, what we're going to do is we're going to have a number of sessions for those of you who really want to continue on the robotics side. So Milena, we are going to be having some more workshops. They may not be on Saturdays though, but what we're going to do is we're going to have a look at how do we actually do that Arduino coding. Brittany is wanting to put together a number of Arduino workshops. So we are going to be taking it forward. However, you can never ever start coding until you actually know what is the job that I want to do and what are the steps that I want my code to perform. So today, our focus is all going to be on our robotics projects. linking to these 3 sustainable goals: 7, affordable and clean energy, climate action, and life on land. And we need to answer these 4 questions. What is the job we want the robot to perform? Why do we want it to perform that? What inputs are we going to use, and what outputs are we going to use? So I think with that, what I'd like to do is that I'd actually like to stop sharing the screen, and let's actually start having a discussion. Brittany, great, that was quick. I did mention to everybody that you were chasing down an internet connection. So that's absolutely great. So what I'd like to do is I'd like to actually start handing over. We have received some submissions already of videos and projects. So we've had one from Riza and one from Grace at least. So maybe what I'd like to do is hand over to maybe we actually start discussing some of those concepts. So I was wondering, Brittany or Colin, maybe if you want to just put up your hands to facilitate a bit of a discussion. Let's take it for the next number of minutes. Okay, Brittany, great. First with your hand up.
Yeah, thank you, Judy. Morning, everyone. What I do want to say about carrying on of what Judy said about knowing before you can even think about code, what it is that you want to do. What I use as a guide, before I necessarily think about my why, I think about what I want to do and then think of my inputs and my outputs, kind of like we were doing in the earlier weeks of this program, where we thought about when we want to do an experiment, we first thought about the question that we want to answer and the data that we need to answer those questions. You can approach the robotics project in the same sort of fashion, where your first question is, what do you want to do? And then instead of thinking of the data that you need, you think about what your inputs and outputs are, because those will give you the data sets that you need to actually give your robot the instructions it needs to do its task that you want it to perform. So an example that I remember from, I think it was either last week or the week prior session, there was a number of students who were talking about moving around solar panels to get the most energy from the sun. And when you think about that, your input for data you'd want is light intensity, UV readings, and then your output would be your degrees that you'd possibly want to change for either a servo or a stepper motor for your solar panels to move. So if you start to think about your projects in that way, it's a lot easier for you to get from idea to execution.
Yeah, perhaps if I could just maybe go straight off the back of what Brittany added. Absolutely. I think, when we look at robotics as a whole, what is robotics? And I think, hearing a lot of your inputs in the past, there seems to be, some sort of confusion in terms of exactly what it is. But I think as a broad, sort of definition, is anything that allows some level of automation, right? And think about, Brittany spoke about the solar panel, right? I've seen one instance where they've actually created a really nice looking solar panel shield that at night, it basically closes up. And then during day, it actually fans out, almost as if like a daisy, and like it actually literally looks like a flower. So it fans out like that. So for it to actually do that, there's motion involved, and it's got to spin the panels out in a particular direction. And then the second action would be, it now needs to look at the sun. And I think it's a wonderful time in the Western Cape around spring, and I'm not too sure if anyone's had the opportunity to look at the daisies alongside the roads and in parks, etc. But what you actually find, nature actually has a way, or the flowers have a way of tracking the sun. And then at night, they literally go to sleep. So the idea from one aspect is to kind of look at something where fan out like a flower, number one, and then number two, point at the sun and then track the sun ultimately. So in that particular scenario, and using Brittany's guideline in terms of, okay, what do we want to achieve from this entire sort of robotic system? I think ultimately what we want is to maximize the time that the solar panels are spending in the sunlight, right? And to do that, we now need to have an input in terms of detecting where are we actually picking up the best possible sunlight. And I think here is where a lot of thinking you need to sort of think about, how do we know in which direction we're actually picking up the most number of sunlight? And we've got to think about, there has to be some type of algorithm as well, right? In terms of figuring out where do we actually pick up the best possible sunlight. So you've got to think about those aspects. The second input could also potentially be light intensity. What time should we open up the flower, and what time should we close up the flower, or do we sort of respond to light intensities, etc. Then the next thing is in terms of the outputs, right? What are the different types of outputs that we need to sort of look at? Well, moving around the shields requires some sort of servo action, right? So you've got the one motion, and you'll find from a robotics perspective, robots are typically given a term called degrees of freedom, right? Or DOF. If you Google that, you'll find tons and tons of information. So how many degrees of freedom would your electronic or robotic flower need, right? So it's going to need to do that, open up the flowers ultimately, and that's 1 degree of freedom. It's going to then need to move left to right. That's going to be 2. It's probably going to have to move up and down as well. So that's going to be 3. And then typically that would mean that you would need to have at least around about 3 different servo motors to manage those sort of those actions. And I'm sort of just throwing a few ideas out there, and I'm hoping to sort of stimulate some ideas, across the forum. And then obviously feel free to raise your hands and jump right in if you want to sort of drill into a particular subject. But yeah, by all means, just go ahead and raise your hands if you need to interject. The second aspect, I think, from what robotics was ultimately intended to do, and going back to the days of the first industrial revolution, right? When we currently find ourselves in the 4th industrial revolution. I'll be very surprised if anyone knows what happened during the 2nd and the 3rd, right? I certainly struggled. I had to look that up, but certainly, the very first industrial revolution was all around replacing manual labor with some type of machine. And the reason we wanted to do that was obviously to increase efficiencies. And it's very laborious, right? I mean, it's not fun to sit, for example, in a field of crops, pull something out from one spot and throw it down in the other spot, and continue to do that for the entire day. And that's where automation sort of, started out. Where could we look at putting in a machine, for example, that picks up from one point and drops on the other? So over time, that's ultimately what we're trying to do from a robotics automation perspective, is to reduce the amount of human labor, especially when it's repetitive, right? If it's just a very common sort of robotic process is sort of a pick and place. So by way of example, you might have a task where you need to pick up all the red blocks from a particular point and place it in a particular red container. And then you're going to pick up the blue stuff and then place it into a blue container, right? So again, using the inputs and outputs that you'd require. And from an input perspective, the robot would need to be able to tell the differences in color. And there are multiple ways of actually doing that. And then secondly, from an output perspective, the servo would need to have the degrees of freedom to be able to pick up blocks from one particular point, move it and rotate in a different direction, find the right bin or container to drop it into, and then drop it from that standpoint. And then just the last point from my side, a very nice application that I've seen is that you might find if you're walking into the malls is that this whole micro farming is becoming quite big. I've seen recently in the Apple store, they've got a really cool, sort of miniature farm with a whole bunch of sensors in it, and you've got, a little robotic arm that basically digs out a space in the sand, and then you put in a different arm onto the robot, and it then plants the seed, and then you put a different arm, attachment onto the robot, and it starts to feed. And then it monitors the soil moisture, it monitors the humidity, it monitors various different aspects around that particular plant, and until over time you actually see something grow. So yeah, just a few ideas from my perspective. Thank you.
Great, Colin. Yes, thank you very much for that. What it is that you talk about pick and place. So these little X chips, we use a robot to make these. This little sensor in the middle here, you can see it compared to the size of my fingers or my hands. There's absolutely no way we can have humans putting these together, because the faults and the inaccuracy is just not going to be tolerable. It's going to be very, what do they say? When one makes, bread from craft bread, we can't have like, these very organic craft electronics. So the thing is, what we did is we purchased a pick and place machine, and then we programmed it. So what it is that these, when we have these PCBs, which is a printed circuit board, we have those made. And then what happens is that these little sensors and these resistors and capacitors and things like that, they come on these ribbons. So the pick and place machine has these reels, almost you could think of like a cotton reel or something like that, but it's like these ribbons. And then what it does is that it then pulls it off, and there's this robotic arm that moves around very quickly and picks it up and then places it on the board, etc. And so yeah, a lot of work needs to go into programming it. But the thing is that once we've programmed it for this particular component, like an SW01, or in my hand, I've got an SW03, then we have that program forever. So what it is we know, okay, that's fine. We've made more of these. We've made, let's say, 1,000 of these boards. So what we do is we can load them into the pick and place machine. We load the program, and then it takes it and it repeats it. So as you say, and honestly, we did a production run for this program, and a lot of the components, we did 1,000 of each. And when we tested, we had errors where one of them, there were 2 that were faulty out of 1,000, and the other one, there was 3. Another component, there was 3 out of 1,000 that were faulty. So the levels of accuracy are just very, very, very high and very acceptable then. So yeah, that's a very good application of how we have purchased a robot, because it's going to do a job for us. A lot of the time, a robot or a machine can do a much better job than we can as human beings. So let's take those jobs and give them to the robots and the machines to do, because what human beings are really, really good at is creativity, imagination, and innovation, and invention. So if we can focus our time there, instead of doing these menial jobs, we're going to have a very, very fast progress. Brittany, I can see your hand is up now.
Yes, thank you, Judy. Just to carry on from what you were mentioning about the pick and place machine, during my time at Moorhead State University, one of our classes was actually to do with microelectronics and designing PCBs and all of that. And then we actually had to learn how to surface mount solder ourselves, which is the type of soldering that's done on X chips, where you don't solder through the PCB, you solder on top of it. And learning how to do that as a human being is quite a laborious process. You need a magnifying, like binoculars, like you have to like, it's really intense. And during my internship at X in a Box, watching the pick and place machine do it so quickly compared to during my time at Moorhead State University, where to do one PCB that was around the size of this whole circuit took me 3 weeks. The pick and place machine did like 1,000 of these in the space of 3 days, maybe, if not less. So that really explains how robotics and automation becomes a really integral part of the fourth industrial revolution, because we've reached the stage in society where technologies become mainstream and that life moves faster, and that everybody having access to technology allows us to move further in terms of innovation of other sorts. So just to bring it back to the whole like robotics and automating things, in terms of your projects, you don't necessarily only need to think about which components you want to use and what inputs and outputs you're going to need. You also need to think about what sorts of instructions do you want to give the robot. So that's what Judy mentioned earlier. The automation is the statement, if this, then that. That's only one like main theme about automation. In this program, you learn the basis of all of that. But when you think about automation and robotics, as Judy also mentioned, robotics is good for menial tasks. Humans are better at creativity and innovation, but there is a sort of middle ground between the two that's known as machine learning. So we're teaching machines how to make certain decisions without human intervention. So robotics and remote control is different, because remote control is where there's still a human making the decisions. So the robot gets certain inputs and then a human has to say what their next step is. Robotics is different. Robotics uses machine learning, where the machine uses the instructions that you've given it, an algorithm that says, okay, if I have this sort of input and this sort of input, then I need to do X, Y, and Z. But if I have a different set of inputs, then I need to do A, B, and C instead. So that's also where you need to think about all of the eventualities that your robot or circuit might encounter during its process of life. So for the solar panel example that I mentioned, as Colin also mentioned, there's difference between what it needs to do at day and night and different times of day. So then you'd need a series of if this, then that statements. That's all.
Brittany, you're very, very right. I just put in the chat that too often we think that a remote control rover is actually a robot, but it's not. It's actually just a remote control rover. And so I can see here that Tafara has made a really great contribution here in terms of vertical farming. So I was thinking, Tafara, do you want to unmute or maybe put your camera on and just expand on that a little bit so we can have a bit of a discussion around that?
Morning.
Morning, hi. Over to you.
So vertical farming, right? Vertical farming is basically what I like to call the future of farming. So people have found out that the normal type of farming where like there's land and then you grow crops is not necessarily the best, because you'll be killing habitats and lots of animals in the process in order to make farming suitable for those crops. So vertical farming is now the next step, where you can grow crops without like real fertile soil and the sun as well, where you can find substitutions for those two factors and you grow them inside as well. And in terms of space, do not take up a lot of space. And I was just thinking about how we have these kits. So for example, in the Zymo box kit, we could have used the soil moisture. Let's say we're growing tomatoes. Tomatoes need a certain amount of water. We research on that, and then we grow tomatoes using the soil moisture with it to regulate the amount of water is needed. One example. And then the servo driver, we need something to move in order, like that hand that Colin was talking about, the robotic arm, where precisely, and thanks to how precise robots are, we can do that.
Yes, Tafari, you're absolutely correct. Vertical farming is terrific. As you say, horizontal farming takes up a lot of land, and also there's a lot of, for example, the Amazon forest. The Amazon forest is being destroyed because farmers are wanting to use it, the land, either for crops or otherwise actually too often for beef farming as well, for cattle. So what happens is that they either burn the jungle down, the Amazon jungle, that section down, or otherwise they'll just go in and cut down the trees because they want to have this horizontal piece of land. So as you mentioned, if we start looking at vertical farming, what it does is it takes up a lot less surface area. And also the thing is that what we have is the water is going to percolate down because of gravity. So, what you could do is you could have your soil moisture sensors at different levels so that you can see, okay, I now need to open my sprinkler at the top. Because maybe my tomatoes at the top are getting too dry, etc.
Oh, yes.
You can also
in
determine your whether you've actually got good soil drainage or not. Yeah. So that's a very great point. And then Brittany, before I hand over to you, I want to share a project that's been run for probably a few years now, probably the last good 10 years in Detroit, in the USA. So Detroit is famous for car manufacturing. And ever since the 2008-2009 crash in the US economy, what happened was that people just stopped buying cars because they didn't have money. Interest rates were very high, so they just stopped buying cars. So a lot of the businesses in Detroit went out of business. And what they did is that they converted those office blocks to almost like food tunnels. So what they started growing food inside. And what they found was that with the artificial light, if they just changed the color slightly of the artificial light, what it did is it could either enhance or detract from the taste of the vegetables. So yes, tomatoes really, really grow well indoors. Other things that grow very well indoors are leafy vegetables like spinach, also carrots, root vegetables like carrots and turnips and potatoes and that kind of thing. They grow very, very well indoors. So yes, there's a great application for turning buildings or office blocks and factories that aren't being used anymore, actually turning that into now producing food rather than producing cars or other kinds of things. So yes, I really, really, really like your example and your idea there. Brittany, you have your hand up.
Yes, it is actually to talk about what you just mentioned. During my time at the South African National Biodiversity Institute, that was one of the case studies we looked at during our wildlife economy research, because there's this move towards sustainable farming and conserving biodiversity in terms of land. So we looked at ways that we could move farming to areas that wouldn't affect conservation for the flora and fauna of like land. So specifically like in South Africa, in the Western Cape, we have a biome that's really unique. So like fynbos, for example, doesn't grow anywhere else but in the Western Cape. So we were looking at ways to take away farming for like horizontally so that we can have more land to preserve the biodiversity. And we spoke to like a lot of farmers, not only in the Western Cape, but throughout the country, about them moving to possibly farming inside. And then we looked at case studies in the US where they took office blocks and deserted malls and changed it to grow food inside. And one of the interesting things was that they could optimize food growth by looking at optimal levels for UV, so natural light, but they'd use artificial light instead. As you mentioned, they changed the color of the light slightly to improve flavor, but also they looked at how much water would the soil need for optimum growth so that they could grow the most nutritious, most flavorful crops in the shortest amount of time, in the most natural way possible. When I say natural, I don't mean like with regards to the light and the soil, but in terms of them needing hormones and other chemicals and pesticides. When you grow food inside in vertical farming, you don't need as much pesticides. You can actually get away with no pesticides and no need for like growth hormones for that crops for it to grow optimally.
Right. Thank you, Brittany. And in the chat, Milana's given us a terrific link. And then also, Varisha, would you like to just share with us in terms of what cloud seeding is?
Okay, so cloud seeding, it sounds complicated, but it's actually easy here in the UAE. Obviously, I'm in the desert. So I found out there's no rain. So that's very interesting. And I found myself actually missing the rain. So then I went to research, like, does it ever rain here or whatever? And then they said, no, they do cloud seeding. And then I was like, what is cloud seeding? So cloud seeding is where they send up projectiles or rockets to disperse iodine or salt or chloride in the air, which causes it to condense. And then it is actually a way to manipulate nature in order to get rain. So when it does rain here, it's actually, how can I say, it's man-made because it's manipulating of nature. So it's very interesting. And that's how actually you see plants and everything grow here, because I'm like, I'm in the desert, why am I seeing plants? And that's how they made it work. So there is rain. It is a holiday when it rains because it rains at such a large amount because of the cloud seeding. So it's actually a very interesting thing of how we can manipulate nature into getting what we want it to do.
Yes, you're very right. As you say, it's man-made rain because it's being encouraged to rain. Colin, I see you have your hand up.
Oh, thanks. I think that's also a very interesting concept, Varisha. I'd be interested to find out from a cost perspective. Number one, what does it cost, and then obviously why hasn't it been, utilized more often? And perhaps there might even be, I'm not sure, on the impact on the actual environment as well. So it'll be quite interesting to hear some of your feedback on that. But as you spoke about it, I thought about a story that I'm not too sure if everyone's quite familiar. It might gross some of you out, so I apologize in advance, but we're all scientists. So I think very recently we've seen that South Africa is featuring on the world stage, and that we are, I think, around about number 12 or number 13 in the world contributing to greenhouse gases. So it's not a great statistic to want to share, but we certainly are having, a very, very massive impact from that standpoint. One of the, and on the subject of farming, right, one of the very big contributors as well to greenhouse gases is coming out of animal farming. And initially, from some of the research that I've seen, that I felt it was related to methane, but more recently, it's actually related to the fact that as the cattle are grazing, they then urinate. That thing goes into the ground, and I think it combines in a certain way. And I think there's nitrogen that's also, impacted as well. And eventually, sorry, I put something in my throat. Eventually, that then releases some gas into the air. So there are some experiments currently going on where they are now, the problem statement is the fact that the cattle are urinating just anywhere on the field and where there's sand. They're currently training cattle to walk to a particular place, and think of it as a cow loo, right, where they go to urinate ultimately, and they're able to catch the urine and safely sort of keep that and treat it in a different sort of way altogether. So yeah, I just find it interesting that we are even looking at other methods where we're training cows to go make use of the loo, and rather not just, go out into the field.
Milena, you have your hand up, yes.
All right, so from weather perspective, it's going to be a little bit more long-term use of these sensors, in a way that we all know that the climate is changing, and it's directly impacting our everyday life quality, starting from, for example, the water consumption. Currently, Gauteng is under water restrictions. We all know what's happening at the end of summer in Cape Town, because we have reverse climates, and it's always difficult. So if we're using, I'm thinking if we're using our relative humidity and air pressure sensors, we can learn in a greater detail how the microclimate in the place where we stay works. And in a longer term, we can make decisions about water consumption, because we can say, for example, let a full weather station run at a particular village, for example, and we can see how the weather changes when the rain comes, in immediately few days before the rain comes. So in a village, in a small place where they don't have too much weather data, they can start predicting the rain, so to speak, outside of the main stations, and they can make a plan with that. But in general, the climate change is affecting the water consumptions, and you can think the water supply rather, and we can think of ways to be predicting that in greater detail if we're using smaller stations in more places. That's my idea, but that's not directly connected to robotics. If we want something to connect it to robotics, I was thinking, Colin mentioned it, but that's actually one of my experiments is micro gardening. So what happens is you have relatively big garden. Some of us have big gardens at the back. And the way the sun goes, there are certain places in the garden where there is no light, and there are other places where there is lots of light. So I've seen it in videos in other countries. They actually do that. They take data of the different spots and they plant plants that say require lots of water or require less water, require lots of sunlight. And if you go on YouTube and you look micro gardening videos, you can see that they plant so many crops just in a small garden. And even on the roofs, rooftops where houses allow that, on the rooftops, and they catch absolutely every single element of the weather possible in the different places. So if you have, say, for example, a normal garden for the suburbs, and you place 4 or 6 sensors in different places, and you get the data for how much sunlight that place gets, how much water the soil have. You can have a garden where in one place you have very water demanding plants, and in another place you can have very sun demanding plants, and you can literally sustain one small household on those plants, just getting different crops from those plants.
Melanie, yes, you're very right. Micro farming it's a great science, and also the thing is that there's a lot of good combinations of plants. It's called companion planting. For example, I do know that basil as a herb with tomatoes, what it is that the basil protects the tomatoes from a number of pests and vice versa. You know, the challenge that we have is when we have a few square kilometers of just one crop with a really large farm, then what happens is it gets attacked by pests. So then the farmer uses pesticide. And then what happens is that the soil gets depleted of nutrients. So then they use artificial fertilizer, you know, and so that we have a lot of challenges, climate change related challenges that come from these mega farms, where you know, it's all about having these huge farms. So going back to micro farming, the way we used to, you know, a few thousand years ago, or even maybe a few hundred years ago, we would have micro farms, and then yes, we would grow a number of different food types. And also the thing is that then one can also start matching the seasons, you know, so you can have a little bit of your own little crop rotation where you can actually plant, so you can make sure that you have a harvest during the year.
It has become a big trend in America at the moment, connected to COVID, because lots of people notice that you can't always rely, and even when we had these lootings, you can't always rely on supply in the shops. So you have to have like a self-sustainable food source. And this micro farming is a very great idea. And I think it's going to be growing up, because people want to, now at this time, people want to be more self-reliant. They don't want to be relying only on outside sources. We've noticed that it's not always a good idea.
Absolutely. Brittany, I see you have your hand up.
Yes, to talk about the micro farming, Milena is right. In the US, it's becoming very popular, specifically during spring of 2019. So autumn for South Africa, but spring in the US. I went on a road trip to the Midwest in the US, and we visited a few farms from friends of mine in the US in Savannah in Missouri, and they started actually doing this like community micro farming. So Savannah, Missouri is usually like cornfields, but then they were realizing they were depleting the soil and there was a lot of runoff, and they'd have a lot of flash floods. In the past 3 years, they were having a lot of flash floods and they were losing crops. So then they realized they had to do a bit of crop rotation. And then they started doing companion farming. Some farms would have a small section of corn, like maize, and then they'd have other things to sort of bind the soil, because they were having a lot of like nutrient depletion, and then the soil was degrading, so it wasn't able to hold together as well. And then during the summer of 2020 and 2021, when COVID was really bad in the US, they were actually self-sustainable, because we all know that they were panic buying in the US. And then those farms actually sustained those communities for, I think it was 3 months.
Absolutely. Yes, Brittany, thank you very much for that contribution. So what I'd like to do is I'd like to open it up to the floor, to our participants who would like to discuss their robotics idea. Izuna, I see that you have a question. Sorry, what is micro farming? Milena, can I hand over to you again, just to define for us what micro farming is?
Yes, it is growing crops on a small area where in different spots in that area, you have different sunlight and different moisture, simply because maybe if it's in a garden, part of the garden during the day is covered by the shade of the house or different buildings or even trees around. So it's not just like a field, one big farm in fields that receives the same amount of sunlight. So you only can grow one crop, but it's actually different growing conditions in a small length. And if we can see the difference in moisture in the different places in that lane, we can decide in which parts we can grow plants that require more moisture and more shade, and in other parts you can grow plants that require more sunlight, less moisture, and we can determine that with our eggs in a box. Because if you have your own yard and you can observe the places in that yard where your house is permanently put in shade, is cast in shade, and in those places you can plant plants that don't require too much sunlight. And also the amount of sunlight in different places varies between summer and winter. And that can also be determined by simply by having our lux meter and looking in the long-term data with that lux meter.
Absolutely. So what I did is that I just also wrote that a little bit in the chats, the difference between micro farming and industrial type farming. Colin, yes, great comment. You're saying here you love the concept of companion farming, especially the basil protecting the tomatoes, etc. You use basil to neutralize the acid in the tomato. Okay, so that's very interesting. Thank you. Others use sugar to neutralize. Okay, that oh, yes, of course. Hence, you will find pizza makers also combine tomato and basil. Yes, so the original pizza from Napoli is where we get the Napolitana pizza, and that is the colors of the Italian flag. So it's the red, green, and white of the Italian flag, the red from the tomato, the green from the basil, and the white from the cheese, the mozzarella cheese. So yes, you're very right. That's probably where it comes from, is that around Napoli, which is on the very close to Mount Vesuvius, they probably very successfully grew tomatoes and basil. So absolutely. So what I was thinking is, Nico, we see that you are here in the chat. Maybe if you actually want to start talking a little bit about, yes, home automation or other forms of automation, because that is really actually that's definitely a form of robotics. So would you like to come into the session here, Nico?
Yes, sure. Morning all. Thanks, Judy. Home automation is actually one of my passions and one of my hobbies. I dabble with that a lot in my spare time. So it's slightly off topic from the farming and the gardening, smart gardening. But I think the X in a Box kits or the X chips lends itself very good to this type of application. You know, you might ask home automation, what am I talking about? What I typically have in mind is things like switching on a light, and we all know we've got the light sensor in our kit. So use the light sensor to track the amount of lux in the room, and then, you know, if it goes below a certain level at a certain time at night, typically when the sun goes down, you can use that as an input. Brittany was talking about an input, and then the output would be, I think, the OC03, which is a relay output. You can then use that as an output to switch on a light or switch on the TV, etc. Yeah, so that's one application. There's a whole wealth of things. There's things on energy as well. You know, I'm thinking of geysers, although there's a disclaimer there, you know, that's high voltage. So I wouldn't suggest you try and do that yourself. You know, playing with geysers, but that is an application where if you're a qualified person to work with high voltage, that you can use as well. There's a lot of it might be slightly off topic, but there's a lot of controllers that you can buy, that you can set up to do a lot of things in the house, to automate stuff, and so on. So I think for now I'll leave it at that. But home automation is certainly another application of automating things, and let the computer or the machine do it for you. Obviously, us as humans comes in where the creativity will come in. For instance, on a lighter note, one of the things I played with is when my wife gets home, there is an app called Life 360 on your cell phone, which tracks your presence where you are from a GPS point of view. And I've set it up with home automation that if she's within 100 meters of the home, then the light in the room starts flickering 4 times. That's just an application, but I think one needs to be creative, and technology needs to be fun, you know. So that's the idea that I want to share with you. Thanks, Judy.
Nico, thank you very much. And I can see Azuna is saying in the chat, I would like to design a robot that could help you with your house chores. Yes, you're absolutely right. There are a number of robots like that. In the US, there's something called a Roomba, which is very popular, and that is a robotic vacuum cleaner. And so what it does is it goes around and it can detect, so it doesn't bump into anything. But what it also does is it maps the room. So it'll remember where it's vacuumed and where it hasn't vacuumed. And also what it does is it, over time, it learns that perhaps around the table, there's sometimes quite a lot of breadcrumbs. So what it'll do is it'll go there at certain times of day to pick up the breadcrumbs or whatever that may be. Yeah, my brother and sister-in-law, they got themselves one during the lockdown, only to find that it doesn't deal with stairs very well. So yeah, that was something that they certainly learnt about. Maxwell, would you like to come in terms of, you've put in the chat, what about a robot that senses that if it's going to rain, or what the weather's going to be like? So Maxwell, I'd like you to discuss that with Milena, because that's her first qualification is actually as a meteorologist. So she knows all about rain. So would you like to come in, Maxwell?
It's actually either Nathan or Natalie.
Ma'am?
Good morning. Is it Nathan or Natalie?
Yes, ma'am. Ma'am, it's Nathan, ma'am.
Hi. So what is your idea? What do you think?
Ma'am, it's a great idea, ma'am, like for some cars, ma'am, like if there's bad weather, ma'am, it can tell if you can like use a different routes or tell you whether to stay home or not.
All right. So first of all, you can only use the sensor where you place it. So you can only use it there. But what you can do is just before the rain is going to start, 3 things actually change. First, you're going to have clouds, so the lux is going to change a lot. Then you're going to have a very, very low air pressure. So the air pressure is literally going to dip in the place where you are. And you can actually notice it. We still don't have rain in Johannesburg, but as soon as the rain starts, we are going to actually show it in the data that in the place where the sensor is, the air pressure dips dramatically, like very fast. The lux dips very fast. And also 2 warnings that in that place in the next about half an hour, it's going to rain. I can actually, in the place where we stay, where our school is, because those are my children, I can feel the drop in air pressure and the temperature, the drop in temperature as well. And it automatically tells us in the next half an hour, it's going to rain. The thing about Johannesburg rains that they come very fast the data, and we can make a little profile in the area where we are at the half an hour, the hour just before it starts raining, and we're gonna see how every time that profile is the same.
Okay, ma'am.
Yes, Melanie, you're very right. I grew up in Johannesburg, so the first many years of my life I spent in Johannesburg, and you're very right. One would be able to predict in summertime, wow, the temperature would change dramatically, the pressure would drop, and then suddenly that would come through. And the reason why I know that the pressure has dropped is because in my family, we suffer from very low blood pressure. So when the air pressure drops, I start suffering. I start feeling as if I'm not getting enough oxygen. So so yes, I've got my own kind of built-in weather meter, and I have to say I'm a lot healthier at the coast where there's more oxygen and where the pressure is slightly higher because of gravity, than I was for most of my life. I can, yeah, absolutely. Longiliseli, I can see that you have your hand up. Welcome. Nice to see you with us today.
Welcome. Thanks, Brittany. Thanks, Judy. Actually, I would like to share my idea. My idea is a concept of inspired by one of your lectures on radiation greenhouse. So since I found that in order to capture high intensity light, it has to be emitted on a certain object. So that is the fundamental of the concept where it's actually conceived. So we will use black cells to trap high intensity light and then convert that amount of light into high voltage of electricity, where we will store electricity using things called capacities and converters. We can then generate electricity for farms. For that, since farms normally they use wind energy, generators for irrigation, for most of the things. And normally when there's no wind, they struggle to generate electricity. So this can be an alternative where we can actually trap and actually keep electricity, and electricity can be actually kept. And also I noticed that there was one of the graphs that you showed us that there were high peaks at 10 a.m. So we can actually leverage in those times to capture high intensity light, and we can also use that electricity to be stored also in batteries, so that we can use those batteries to power Antarctica, further other experiments, since there's minimal support of weather, and we can even go beyond in actually rippling buildings with that kind of system, with solar like black sails wrapping around the building, so that the building can generate its own electricity using the solar, using sunlight. And we would use sensors, like light sensors, to trace the amount of light intensity, which is SL01. We'll use weather sensors, CW01. We will use our input rate. We will use IPOs. Also, your inputs would be, well appreciated.
Oh, great. Yes, I must say Your idea is very well timed. Yesterday I was in the outdoor warehouse, and I actually saw that they've got these folding solar panels that fold into actually quite a small case, but you actually fold them out, and they're these black solar panels that you fold out. And then what it was is that then there was a connector to a typical car battery, so that what you could do is you could, wherever you are in the wilderness, what you could do is you could actually just fold out these black solar panels, and you could charge a battery, so you could harvest that, so they weren't these fancy glass solar panels that we find that are installed on roofs and all of that kind of stuff. It was very much a portable black, kind of like, in a way, fabric-based solar panel. So yes, that was really very interesting, where you could actually take this with you. I do know that in Mpumalanga, a number of the coal mines, especially if they do shaft mining rather than open cast mining, they've got a lot of surface area, with the mine being underground. And what they're doing is that they're erecting wind farms. So when the wind blows, they're able to generate electricity from wind. And then when the wind doesn't blow, what they're doing is they also, underneath the windmills, they also have a solar farm, so that they then generate solar electricity, at the same time, especially if the wind isn't blowing. So, it's quite ironic, because these are coal mines. But also the thing is, what happens with any kind of mine, whether it's a gold mine, a platinum mine, a coal mine, eventually you've dug everything out that you can. So, the life of the mine comes to an end. So now these coal mines are being converted to green energy producers. So that's very, very interesting. Karine, I can see you have your hand up.
Good afternoon, guys. Ma'am, can you hear me?
Yes, we can hear you. Yes, Karine, it's Judy here. Yes, please go ahead.
Okay. Miss, I just wanted to share my robotics idea. It's mainly centered around what we've been speaking about today. So I've come to a realization that in most rural places there is no electricity. So I came up with a solution to use wind energy to generate electricity. But there is a problem in the rural areas, because people don't have facilities to know what weather it is. So it would be harder for them to use the windmills. So my robot, in my robot, I'll use the SW02 to detect humidity, as higher humidity is associated with lower wind speed and vice versa. And I'll use the CO5 to turn the robot to the direction according to the humidity. In this way, people in the rural area will be able to know the weather. The speed of the wind, so that they know where to place the windmills. I don't know if this makes sense.
It definitely does make sense. The thing is that a windmill would need to be, permanently positioned. But what you would do is, using your robot, you would be able to identify where the best spot would be to build that windmill. Certainly. So yeah, that is a great application. Most certainly. What I'm thinking is, I'm having a look at the time, and it's 11 minutes past 12. So what I would like us to do, would it be okay if we take a 14-minute break? So if we come back at 25 past 12, let's take a quick 15-minute comfort break. If we can come back at 25 past 12, and then we can keep going, and then if it's okay, then we can conclude around about 1:15, if that's okay. Milena, I see you have your hand up. Maybe we just go to you quickly.
Very quick questions. Does X in a box has a chip that can measure wind speed, an anemometer? I think that's what it's called in English, anemometer.
We actually don't. We seriously considered making one. Our challenge was that they're very analog. So our challenge was actually converting that analog to a digital signal. So we never actually made one. We would love to be able to make one. And we also really what we would like to do is also to measure rainfall. But that's also a very, very mechanical process. So yeah, unfortunately we don't. You know, the thing is that with Internet of Things, if we were to have thousands of sensors, let's say over an area, just by looking at pressure differences, we may be able to start converting that to maybe a wind speed map or wind direction map, something like that. So yeah.
One that's out there, I think that's the best, because remember you sent us that map, that application with wind speed. That girl that was giving that example can look into that application. If you can just put the link to the chat for the wind application.
Yes, certainly will. Yeah, that was Corinne.
Thank you.
Great. Thanks so much. So yeah, if we can take a break. In fact, I'm looking at the time now. Let's get back together at 12:30 and we continue. So yeah, coming back from the break, what I'd like to do is I'd like to go first to Brittany. Brittany's got some input to make in terms of the wind speed measurement and an application, a really great application that's out there. And I'd also like us to have a look at the experiments and the assignments that are due. It's very, very important that you become very comfortable with the various dashboards. So Brittany, what I was thinking is, we do have those two generic dashboards that we developed for UNDP. So maybe if you actually want to take everybody through, how do they find that generic dashboard, based on the sensors that they have in their kit. So yeah, at this point, can I hand over to you, Brittany, to maybe first of all look at wind and then to take everybody to the dashboard so that they can easily see how to use that.
Can I share my screen? It says
I need to, okay, sorry, I need to make you a co-host. So sorry about that. Is it working now?
Yes. So the website for wind speeds that I find very helpful is actually windy.com. I shared it in the Slack. Milena might be able to describe this way better than I do, because I don't have that background that Milena does have. But essentially, this shows you the wind directions and the type of wind, so whether it's cold or warm and whereabouts it's coming from. And then it will also show you how strong the wind is from the location that you're looking at. And then for the dashboard, the generic ones, depending on which sensors you have, you'd go to the dashboards tab, and then you'd search for, if you have the SW1, you'd search SW1. There's a generic dashboard for SW1 and SL06 with SW07, and then there's a generic dashboard for SL01, SW02, and SW07. And then there's also a weather station dashboard that pulls from SW01 and SL01. So that would be this generic dashboard. 00 weather station dashboard, save as your own. And what's important about
Brittany, sorry, I have to interrupt you there. That last one that you showed, that would mean that they've actually flashed a different software. They would have to have flashed XK01 Kibana for that one to work. So it's actually the other two. It's only the other two that run UNDP software that everybody's flashed. Sorry about that.
It's okay. That was my mistake. But if you're using, as Judy mentioned, UNDP STEM, these are all of the visualizations that's already there. And what you do want to do when you're using this dashboard for yourself, you'd want to hit save as a new dashboard and rename it. You don't want to mess with the generic dashboard because this is a sandbox environment. You want the generic dashboard, the template, to be available in its original format for everyone to use. So that's a very important step. Hit save as new dashboard and then rename it. I'm not gonna be doing any of that now. So I'm just gonna, when you want to search for your own kit on this dashboard, so what you're looking at right now is an average of everyone's kits that are connected right now, the inputs that you're getting from it. So what you'd want to do, you'd want to search in front of this asterisk for your kit name. So I'm going to search, I don't have a kit connected with me right now. Judy, can I search one of your kits?
Yes, please. You can have a look at, yeah, let me just see. Hang on, let me just see which one I'm running with those sensors. So that's SL01 and SW02. Okay, so you can search for paprika, just do PAP.
Okay, when you wake up, paprika. And then it will show all of the readings from that specific kit. Thank you, Judy. When you make sure that it's the name of your kit, so what you named your kit name during the provisioning process, during flashing with X in a Box Uploader, once you're in the dashboard and you've saved it as your own, and you want to look at the data from your specific kit, from the generic dashboard that you saved as your own, you want to put the kit name in front of the asterisk. And that's about how you'd use Kibana for the generic dashboards. And you can also, there are different types of dashboards. You can go in and look at all of them. There's a lot, but you can also create your own dashboard if you don't want to use the template. And you'd say add new dashboard. The way I prefer to do it is make visualizations before I create the dashboard, so that once I create the dashboard, I can just add visualization. So you'd go to visualize and you'd say add, and then you'd make a visualization. So you'd be able to, just for example, choose like area chart, cohort analysis, data table. There's metrics and line charts, depending on what you need and how you want to visualize the data, you choose that. So for example, we could take a metric and you'd want to choose your index. So the index that we always use with UNDP STEM is weather station. That if you flashed with UNDP STEM, that's the index that you would pull from. So you choose your index, you'd say what kit you want to choose the data from in front of the asterisk like you did with the dashboard. And then you'd add metrics and choose what you want to make the visualization as. You'd save the name. And then when you go to dashboard and you find your dashboard, so even after you've made the dashboard, you can choose visualizations and edit the dashboard as you wish. I have a dashboard. I have a dashboard here. You can add new things to the dashboard, and you can delete visualizations with this X in the top right-hand corner, and you can move around the visualizations with the arrow box in the same space. You can make it bigger and you can edit it. It says no results found because it's not pulling from any sensor. And when you see this frowny face, no results found, that you want to pay special attention to, because that's an indication that you aren't getting any data and from your configuration. So whether you're pulling from the wrong kit, your kits may be not connected, or you're pulling from the wrong index. So you go through a series of steps to troubleshoot and see, okay, am I using the right index? Am I using the right software for that index? Is my kit connected? Am I pulling from the right sensors? I think that's about all from the dashboard.
Yeah, before you move away from there, okay, if you wouldn't mind just sharing your screen again. Yeah, it hasn't been pulling any data in the last 15 minutes.
Yeah.
So what you can do is you can go up to the top there and you can open that and you can say,
in the last
30
hours.
days, even.
Yeah.
Okay, go to last 30 days. And then what it is that it'll come up and it'll start, you'll see it'll give you some data. So then what you can do is then you can actually then zoom in on that. Just because it isn't connected right now, it doesn't mean that it hasn't been working in the past, because whenever it is working and whenever your kit is connected to the internet, it is saving the data on the server so that you can always go back to it. So yeah, you know, if your kit has got the same name, and you can go back 2 years, you know, if you've been calling it the same thing for the last 2 years. So definitely that's what you can do, is that you can zoom in on where that is.
You can also choose a specific date and time. So I know for one of the experiments, I think it was the daybreak experiment, you had to do it over a certain period of days. If you did the experiment and then you're doing the data analysis a few days later, you can actually go into Absolute at the time section in the top right-hand corner, and you can choose the days or maybe specific times that you want to look at. Same for the fridge light experiment. You maybe did the fridge light experiment at, say, between 12 p.m. and 3 p.m. on last week, Sunday. If you want to look at it, say, on Monday afternoon, you can go back to that specific date and find the data for that date. And also you can go to Quick. Quick will show you specific times, as Judy mentioned, day before yesterday, yesterday, last 30 minutes, all of that, month to date, week to date, and then Absolute is for specific dates.
Yeah, that's absolutely great. So what I'd like to do is, are there any questions from anybody in terms of those experiments, conducting those experiments? Okay, so I'm not hearing anything. What I'd like to share with you is that it is actually really important that you do those experiments. One thing that I've definitely learned in my life is that theory is one thing, but actually doing something, attempting something, is a completely different experience. And if you want to be able to build any of your robotics projects and put them into action, you're going to have experience of how do you actually work with data. And so therefore you're going to have to know how to work with this dashboard. You're going to have to practice in terms of remote sensing and remote data collection. So that is why those experiments are absolutely crucial, finding your way forward. Do we have any more questions from anybody Or are we actually done with our program?
Judy, there's a question from Unati, a direct message she just sent me. So do we just screenshot from the dashboards for the experiment?
Yes. In the experiment write-up, what it is that there were a number of questions that you needed to answer. So yeah, a screenshot is great, but what you need to do as well is you also need to actually articulate that you have actually answered those questions. So let's say, take for example, that experiment, does the fridge light go off when I close the fridge door? So that is the one question that you need to answer. And then the other question there was another question you needed to answer, and that was, which data sets were you going to collect in order to show your results and why? So yeah, it's more than just having the screenshot. Definitely you need to have the screenshot to demonstrate that you did the experiment and you did collect the data, but then you also need to actually answer those questions. And exactly the same with the daybreak. Does it still get colder after daybreak question? Right, I can see here there was Riza. I actually had an idea when I was doing the experiments. I was doing the daybreak one, but was confused how it was cold. But when I did the fridge one, it actually really helped to answer that question. Okay, Riza, I'm not sure if you actually want to chat about that, about what you experienced with your daybreak experiment.
Morning, everyone.
Hi, hello.
Okay, so the daybreak one for me was a bit of a confusing one because I was asking myself the whole time, how is it colder at daybreak? But so I decided to do the fridge one. So when we open the fridge, we know the light goes on and we can feel the coldness coming out the fridge. And when we close the fridge, the light goes off. So I was thinking at nighttime, obviously there's no sun. So the surface of the area is going to be colder. And when the sun comes up, like at daybreak, it's still going to be cold because the air on the surface has to be get warmer from the sun. So that way it is the coldest part of the day, which is daybreak.
In a way, you can't necessarily relate what happens with the fridge, because that is with a fridge, what you're doing is you're actually using a refrigeration process and a compressor to create an artificial environment inside that fridge. So it's very difficult to relate that to what you would have in a natural environment. The temperature at daybreak has got a lot to do with the sun, because it's the sun's rays that are actually heating the atmosphere and heating our surroundings when we're outside. So that is more about the relationship. It's more about how much sunlight you're getting after daybreak that's affecting your temperature. What I'd like to do is, I can see Lungulaseli, you're actually saying here in the chat that you're still having a challenge in terms of the dashboard, that it's saying not private. Okay, what that is that's got to do with very much the settings on your actual computer itself and with your laptop itself. What you need to do is, I know it's not a private website, it's a public website. So you need to click OK or allow or something like that. Unfortunately, we can't help you with that because that's the settings on your computer that you need to change. Yes, Brittany.
I did give him a link to norton.com that troubleshoots what to do when faced with that problem. He's saying that he didn't know which of the options to choose on that website to troubleshoot. My advice to him from an engineering and technological perspective, the process is in engineering and technology in general, when troubleshooting is, there are a series of possible solutions, and to find the solution to your specific problem, you need to go through each one of them in sequential like order and tick off, okay, did this work? No, it didn't. Next one. Did this work? No, it didn't. Next one, until you find the one that works for you. So I gave you that link so that you can go through all of those possible solutions to see which one works for you. It would take too much time for me to do that for each specific student. Hence, I gave that link during one of the initial workshops when other people had that problem. And then in every single Wednesday session that I've attended, so that you, for each student, can individually learn how to do that process in and of itself. Because when you are an engineer or a technologist or a technician, that becomes 60% of the job, learning how to troubleshoot, and that's the process you have to follow. You wouldn't be learning if we did it for you.
Absolutely,
And
that's
then
great. Yes.
There was a DM that I got from Tahira. She was asking for the daybreak experiment, over how many days do we need to collect the data for this experiment. In the write-up, you'll notice that we don't tell you a specific amount of days, because we want you to figure out which amount of days you do it over to get the best result. So maybe you want to do it over a week, maybe you want to do it over a day, maybe you want to do it over 5 or 3 days. It's up to you to see how you're going to get the average to give the answer that you feel would best answer the question. So that we left it open-ended, so that you can kind of have the freedom to follow the scientific process and see where you think would be best to find the answer. Right.
Yeah, Brittany, absolutely. So what I'd like to do is, when I did this experiment for the first time, the daybreak experiment, what I did is that I collected my data overnight, and then and through daybreak, and then I found that it was inconclusive. Because the data was all over the place. And the thing is that was when I realized that our neighbor, he works very strange hours, so he would turn the light on, and so I was getting these peaks, and it meant nothing. So I needed to move my kit, and then I needed to collect it. I also realized that the only way of actually detecting whether it was daybreak was that I had to actually look at my UV index, because that was the only indication I was getting that it was actually sunlight and not the neighbor's light. So that is why what you need to do is you need to collect data a number of times before you realize, okay, this data I can actually use. This is conclusive data. And that is also really why we want you to conduct these experiments, is because you need a lot of what we do is we need to learn from experience. And the thing is that what you're going to notice, it's actually so interesting, because very early on in the days of X in a box, what happened was that one of the students said, it's not working for me because my little brother gets hold of my kits and he blows on it all the time, so my data is useless. So the thing is that what we need to do is we always take responsibility for our own data collection. So the thing is that what you're going to find is that if it's inconclusive, it means that you just need to make sure that your data is being collected correctly. And what I want to do is that I want to go back to that example that we used right in our very, very, very early workshops. What we did is we looked at the solar eclipse. So what I'm going to do, if it's okay, is I'd like to go back and I'd like to go to a dashboard, and let's have a look for that solar eclipse dashboard. And now that you've got some experience, what you're going to do is you're going to see here this solar eclipse. Okay. So you can see that this data was actually collected, and when we saved this dashboard, we saved it with the date and time, so that whenever we go to it, we come back to this particular date and particular time. So we can see here that during this period of the solar eclipse, we can see the light is coming off and then it's recovering. So we know, and it went down to almost zero. We know it is sunlight because of the UV sensors going all the way down, also during the full eclipse and then recovering. So this was the first version of the SL01 light sensor. We used to differentiate between UVA and UVB, whereas now what we do is we do the calculation on the chip so that you get a UV index, because that's a lot more informative. Brittany, let me just complete this if you don't mind, and then I'll come through to you. So you can see here that the humidity is responding to that light, the pressure is responding, and the temperature is responding very, very, very well. So if I were to take this data, if I were to download it from my data table, and I were to take the lux data, and I were to take the temperature data and run a correlation, I will find that there is a correlation very, very, very close to +1, because as the light decreases, the temperature decreases, and I'm expecting that. So I would expect that there would be a strong correlation. So when you're considering how accurate is my data collection process, how reliable is my data, what you do is you take various sets of data or various parameters, and you run correlations, and you actually see if you're starting to get any kind of correlation, or if you've got zero. If it comes out at zero, it means there's no relationship, there's no correlation whatsoever. And you can often use that as an indication of data integrity, or the level of your data integrity that you're using. So if I go back to the daybreak experiment, when I did it the first time and I ran a correlation between temperature and lux, I was getting zero correlation. It was all over the place. And that was when I realized that the neighbor was turning his light on and off at various times of the day, the night, because he was working night shift and all of that kind of thing. So therefore that was really affecting my data. So therefore I couldn't rely on that particular data set. Brittany, now would you like to take over? Do you want me to stay on this screen?
Yes, please. It wasn't about the specific thing. It was a question for after you were done that we received in the chat about the dashboard. So the error was this container is too small to render the visualization. So maybe if you went back to the dashboard and showed the student where that error might be coming from and how to correct that.
Okay.
I suspect they are taking a set of data that's too small, or they are selecting a range that's too small for the visualization that they want to do. So perhaps they're trying to make like a pie chart, and their data goes to less than like 100% or something like that.
Brittany, that's very difficult for me because I've never seen that error myself. So I don't know how to replicate that situation.
Maybe the individual can share their screen to show us, or
just in terms of which visualization it is, or so we can just try to troubleshoot that. Yeah.
Do they want to unmute?
Sorry, now they're coming online. Just a remark, maybe the time intervals are too big. Maybe if they make smaller time intervals and try to get the visualization, like the smallest minute or 15 minutes or whatever time interval, and try to get the visualization, maybe it will happen. Because depending how long they've been collecting the data, so, but if they've been connecting it for a longer period of time, you just make the time interval smaller and see what's happening. That's my idea.
Okay, it says this container is too small to render the visualization. You know what we can do? There's another way of doing this. Just Google it. So what I'm going to put here in my search, I'm going to put Kibana. I'm actually going to copy and paste the text. Okay. Let me actually share my screen so I can just show everybody what I'm doing here. Okay, so what I'm doing here is I'm going to go here and very simply what I'm going to do is that I'm going to go to Google. Google.com. Okay, when in doubt, let's Google it. And we know we're using a tool called Kibana. So we go here, Kibana, and then I'm just going to paste that text. Click enter. Okay, here we go. Container is too small to render the visualization. That's only Elasticsearch. So let's actually just go there and we can see what are they saying here, because maybe somebody's answered that question already. Okay. Oh, where's the question? Okay, sorry, maybe here we go. I'm using Kibana, blah, blah. We create 14 visualizations, 3 dashboard. Each dashboard contains that. While I'm getting this container is too small, etc. Okay, please suggest some solution. Okay, the reason is slow. You probably have terms aggregated in a field with a lot of unique values. Can you share the query? Okay. Okay, this is this is extremely technical. So what I'm going to do is let me actually go to Kibana. Can you see I'm on Kibana right now? Can everyone, can you see I'm on Kibana dashboard now? Is it still on Google?
It's on Kibana.
Okay, so this is the very important part of it, is that whenever we go in data.xinabox.cc, and our landing page is always going to be discover, and it's going to be weather station index. Okay, not any of these other indexes, but weather station index. So what I'm going to do is that I'm going to search for one of my kits. Okay, so I know that I've got one that is called paprika. Okay, and I'm going to search. And what it's going to do is it's going to show me, there it is. This next step is absolutely crucial. So please concentrate on this step. I open up that field and now I have a look at which sensors I have connected and what it's calling that field. Okay. So for example, for Lux, it's calling it SL01 Lux. And the reason why I'm telling you is because when our developers develop in different indexes and different coding packages, all of that kind of thing, it's very important what they've called that field. Okay, so over here, SW02, air humidity %. Okay, sometimes if they're doing a project that doesn't include like soil moisture temp, a sensor or whatever, then they may actually say air moisture. Otherwise they just say relative humidity or whatever it is. So you need to have a look at your kit. What is it actually calling that data? Okay, so what I'm going to do is I've got here SL01 Lux. Now what I do is now if I go to building a visualization, so I'm going to go to visualize. Okay, let me go to the main menu of visualize. I go plus because I'm going to create a new visualization. Okay, what I want to do is that I just want to do a line chart. Remember, weather station index, always weather station index. Okay, and it says here, what do I want as my y-axis? Now, the thing is that what you need to do is you always need to use average. And the reason why you want to use average is because your sensor is recording data every 10 milliseconds. So when you've got a data point, it can only refresh every 5 seconds. All right. So 5 seconds, if you consider that the data is being posted, it's being measured every 5 milliseconds. That is like what? That's like 100. So that's 500 data points for each record. So what you need to do is you need to have a look at average. You're not going to look at sum, because then it's going to add all of those together and suddenly it's going to be way too big. So you go for average. And what was my field called? My field was called SL01 lux. You can see how many fields there are. The fields, you know, there's a lot of fields. So SL01 lux, okay. And then I'm going to apply those changes. I wanted it for paprika, so I've got to put that in as well. Paprika, and let's search for that. And then we go here. But what it's doing is it's only giving me 1 point over here, okay, my average. What I need to do is I now need to do my x-axis. So with the x-axis, what we do is it needs to be date histogram. And I'm sorry to say, I've just got to say, because I say so, that is the way it's been set up in our server for the last 4 years. So we always go for date histogram, and that is going to be time and date, okay? And then I apply those changes, and now I get my graph. So my suspicion is that maybe what you're doing is maybe you're not doing average, maybe you're doing something else here, or maybe you're just keeping it as count. Maybe that is why it's just saying the bucket is too small or something like that. I'm not sure, but it, yeah.
Brittany. They could be choosing a specific date or a specific like time period, and then doing an average or count or something, and then the x-axis is too small for what they want to show.
Absolutely. So I'm not going to save this one. So I'm just going to go out of here. Okay, so I'm going to stop sharing. So do we have any indication of how that happened?
No, I've asked them to unmute and they haven't, and I've seen the DM, but there's no response. So
okay, Milena, I can see you have your hand up.
Sorry, I had to put it down. Sorry.
Sorry, yeah, that's absolutely fine. I'd even muted myself. So what I'd like to do is I'd like to close out now. Are there any other questions? Are there any other comments from anybody? Okay, so what I'd like to do is, as part of our closeout process, with our mentors and our facilitators, maybe we do the rounds. Maybe let's start with Milena, and then Brittany, and Varisha, Nico, and then finally Colin. If that's all right, if you'd just like to make some closeout comments. So Milena, let me start with you.
Judy, to you, thank you very much. It's been extremely informative to be on this program. To all the learners, I can just wish you success, and please don't stop being curious, because that's the most important thing.
Great, Brittany.
Thank you, Milena. Thank you, Judy, for having me be part of this amazing program. Thank you to my fellow mentors and facilitators. Learning from you has been amazing. And thank you to the students. It's really been really amazing to learn from your perspective and see things through your fresh eyes. And I look forward to seeing all of your submissions for your robotics projects. I wish you all of the best in your learning journey, and you all have my email address. If you have any questions, don't hesitate to send me an email. I look forward to seeing what sort of budding engineers and technologists and innovators in future that you become. Please don't stop being curious, as Milena said.
That's absolutely great. Brittany, thank you very much. And Varisha, over to you.
Like I said, thank you. There's a lot of thank yous going around because we appreciate this opportunity so much. If you think about it, like sometimes, even though I'm an educator, I feel like I'm illiterate when it comes to technology. And it's the best when your kids can teach you something. So I don't want to say children, to our students that we have mentored, you know what, it was a both learning process for us and you yourself. That's why you must always have it at the back of my mind. I am never too young to learn something, and I am never too old to gain some knowledge. And that is science. Science is an ongoing process, and you must always, always want to achieve more for yourself. And I feel like, although because I was in the process of a move during this project, I wanted to do more, be more, but I couldn't do that because of so many things. But I was even, like I said, if you look at cloud seeding, don't only take what is happening in South Africa, consider the world as a whole. Your ideas, like for example, the cloud seeding idea, I thought, okay, in South Africa, when we have drought, could we consider this idea? Would it work? Would our budget work? What are the constraints and the limitations and the criteria you need? So yes, you are part of this project and it's fantastic, but also take it one step further. If you want to learn something, also when you're young to gain your career goals, it is so important, because if I had this when I was younger, I feel like I would have been a totally different person. I would have gained so much more. And the opportunities for the young are opening up now. So I think you should grasp it with both hands and then proceed from there.
Risha, yes, thank you very much. You are absolutely right. I have learned so much in the last number of weeks because we've had to do so much troubleshooting. I have learned so much more about the technology that I helped start, you know, many years ago, 5-6 years ago. Definitely. So Nico, I'd like to hand over to you.
Yeah, sure. Thanks, Judy. Yeah, it's been amazing being part of this journey. For me, what stands out is the excitement from the learners and the participation. That is great. And I would like to say, you know, always be a learner. Become a lifelong learner. Even myself, you could see my gray beard. I'm still learning every day. So be a lifelong learner. Doesn't matter what your age is. And just the last word in general. You know, we discussed a lot of stuff. Some is technical, and Colin and Brittany really unpacked it well. You know, touching on inputs and outputs. You know, and so on and so forth. But it sometimes can be daunting. It can sound like a lot of things that you have to consider. Just from a personal experience point of view is, you know, do it piece by piece. Start with the one thing. You know, for instance, look at your inputs. If you want to do an idea, look at inputs. Gather your mind, make some notes. You know, then look at the outputs. Then look at your flow. And sometimes what I do is, if it becomes too much, you know, I get a headache or what, you move away from it, leave it for a day or two and then come back. So this is just something I want to share with you, but just keep on going on. You will be amazed with what you learn in the end. And also share it with other people, you know, teach other people, tell your parents, your fellow students, because you will then actually realize what you've learned. Thanks, Judy.
Wonderful, Nico. Thank you so much. Colin, let me hand over to you.
Great, thanks, Judy. Yeah, how do I stack up against all my colleagues before me? But suffice to say that I think 2 points I want to make in terms of being given a tool set. So I think if anything, this particular program has provided another spanner, right, in your belt of tools ultimately. I think this program has also provided you the capability of building new tools. If anything, we've covered elements of designing scientific or building scientific instruments, right? So building an instrument to go into a fridge to answer a question for you, or building an instrument to answer the question about temperature change during daybreak, etc. So I think always start with a question that you want to answer. Secondly, you've got tools that have been handed to you. Utilize the tools to build a scientific instrument, to observe and experiment. And yeah, I think I've noticed that obviously, Reza, you sort of were struggling with the fact around it doesn't quite make sense intuitively for the temperature to drop at daybreak. But it's, and I guess this is what life is all about. It's what science is all about. But I think do the experiments, record the data, and the data will start to reveal the truth ultimately to you. So, and then I think perhaps I just want to end from my perspective. One of the great role models in my career and in my personal life is someone called Neil deGrasse Tyson. And if you haven't heard of him, etc., Google him. You will absolutely love his talks. He's an astrophysicist, and he explains the most complex things in the most simplistic ways. And one of the quotes, and I think in keeping with the theme of my colleagues before me, he mentioned, in the end, it's the people who are curious that change the world. So, perhaps with that, continue to be curious, and in doing so, you will ultimately change the world. And again, thank you to my fellow co-facilitators. Thank you to Judy, and thank you to the sponsors of the program, and of course, our students on the program itself. Good luck.
Great. Colin, thank you. Thank you very much for that. So in final closing, what I'd like to say is this is not the end. It's only the end of the beginning. And so you've got us, whether you like it or not. So the thing is that what we do is we conduct many experiments and many programs every year involving X-in-a-Box components. And so what I'd really like you to do is stay in contact with us. I'm going to be inviting you to many more projects where we put kits on the International Space Station. In 9 months from now, in July next year, we're going to be putting some experiments onto rockets going into space. So the thing is that what we're going to do is we're going to make sure that you're invited to participate in all of these projects. Some of them you'll have time to participate, others you won't have time, but that's okay. We're going to keep asking you, we're going to keep inviting you, so that you can actually build on your knowledge, you can expand your collection of X-in-a-Box chips, because we have got over 80 different X-in-a-Box chips, and you don't have many in your hands, but as we expand the programs, we start using more and more and more of the components that we have. So I'd like to say, please do your submissions before the deadline. There's some really nice awards that are up for grabs with that. And also have a look out for more invitations to further programs. And yeah, I look forward to seeing you all again. So thank you very much. And yes, thank you very much to the United Nations Development Programme and for the Danish Embassy in South Africa for making it all possible, because they were the ones able to raise the funding. So with that, from me, it's goodbye. Until next time.
Okay, thanks very much.
Thank you, everyone. Bye.
Bye-bye.
Thanks,
Thank
everyone.
you.
Goodbye.
Bye.